Hi there, and welcome to my lesson entitled String Theory for People of Average Intelligence. Now, string theory is one of the current theories that attempts to reconcile quantum mechanics with general relativity, as well as unify gravity with the other fundamental forces in the universe, in order to complete the unified field theory, otherwise known as the theory of everything. Now, if that sounds complicated to you, don't worry, it is. The aim of this lesson is to tell a story that maps over the math and the rigorous science and testing that this theory has gone through in order to make it palatable for the everyday person like you and me. Now, because of this, an expert physicist watching this video would be able to point out several fallacies in the way I'm about to explain this to you. The point is, I am not an expert, and neither will you be after watching this video. This is just for your basic understanding. To start off, we're going to talk a lot about the Big Bang, or the theory that explains the beginning of the universe and therefore the beginning of time as we know it. The Big Bang theory states that the universe began right here, at this point. All of the matter and energy in the universe was concentrated into one uniform point, which we call the singularity. Now, remember that because it's going to become important in a little bit. Now, we're going to zoom in on the early moments of the universe. The universe was shifting from the singularity that it was to the universe that we know now. The laws of physics were coming into existence. As you can see, we believe that gravitation was first, followed by the strong nuclear force, then electromagnetism, then the weak nuclear force. Part of the task that theoretical physicists are trying to accomplish is to unify gravity with the other three forces. We can obviously see that it all fits together in actuality because our universe stays together with all the forces and gravity working in tandem along with us. The problem is, on paper, scientists are unable to form an equation that unifies gravity with the other three forces. On paper, the other three forces, the strong nuclear force, electromagnetism, and the weak nuclear force, all work. The math just does not work with gravity yet. However, we know that gravity is real because I'm not floating away right now. But that will lead to the mathematicians. Right now, I'm here to explain the basic concept. Let's move on and talk about the strong and weak nuclear forces. Back here to the classic model of an atom, we can see that in the nucleus, there are protons and neutrons tightly packed together. They are so tightly packed together that separating them would cause a chain reaction that could and has destroyed entire cities. The force holding these two together is known as the strong nuclear force. Looking outside the nucleus, we have these electrons orbiting the net positive charge nucleus. This happens because the electrons have a negative charge and are attracted to the positive charge of the protons. This is the basic principle that opposites attract, and this is called the weak nuclear force. Now again, this is just a story I'm telling you. It's way more complicated than that in reality. An atom looks nothing like this. These subatomic particles are not circles at all, or spheres, or whatever we make them look like in our models that attempt to simplify them so that we can understand. Even when we observe atoms with the strongest microscopes we have, we still can't get a clear image of subatomic particles that make up atoms. When we see anything with our eyes, what we're really seeing is the light bouncing off of that object. The problem with subatomic particles, like electrons for example, is that they're so small that light waves have too high of a wavelength that they simply go around them. In order to see an electron, we have to hit it with a much higher frequency wave, so we'll use things like X-rays. The problem with that is that X-rays are so high frequency and therefore high energy that when we hit the electron with the X-ray, it actually knocks the electron out of its current position and changes the electron into a different particle entirely. This means that we can never actually know where an electron is when we are observing it. We can only say where it was. Now you may be wondering, if everything is made of atoms, and atoms are made of protons, neutrons, and electrons, what are protons, neutrons, and electrons made of? Great question. Subatomic particles are made of quarks, bosons, and leptons. And for the sake of time, I'm not going to go into detail, but the point is there are different types of each of them, and different combinations of them form the different subatomic particles that we know of. This presented the idea that if a particle could be changed into a different particle by hitting it with a certain amount of energy, perhaps all particles are made of the same thing. And that is the idea behind string theory. See, proponents of string theory believe that all particles are made up of these little things called strings, and they are all the same thing, just vibrating at a different frequency, for example. That's the metaphor that we're using in this case. In the same way that the visible light wave and the X-ray wave are both electromagnetic waves, just acting differently, these particles, quarks, bosons, and leptons, might all just be the same thing acting differently. And that's where things get interesting, because it brings us back to our original Big Bang Theory, where everything was once all one thing. You see, if different combinations of quarks, leptons, and bosons form the subatomic particles, of which different combinations of them form atoms, of which different combinations of atoms form molecules, of which different combinations of molecules form compounds, and of which different combinations of compounds form all the substances that make up everything we see in the universe. So perhaps everything in the universe is just this singularity split apart into different pieces, all acting a little bit differently, creating the illusion of space and matter and energy being separate things, when in fact it is all one thing. And that is string theory for people of average intelligence. Thank you.